Hello, Dr. Gross's lab. This is Fred. I have work right now, so I'm unable to make it to the meeting. So for my portion of the presentation, I'm just making a quick video. And my portion of the presentation is on bait dependency testing. And so what bait dependency testing is there for is really to make sure that the results that we are getting are not false positives. It increases the accuracy of our results. And make sure that the protein-protein interactions really are dependent on that bait, on our HspB2. And so in our screen we've come up with a number of different results that were discussed earlier in the results section that are interacting with HspB2. And so we take these results and we make sure that they are interacting because of that HspB2. And so in this diagram here it shows this basic process where we've basically isolated this protein and then we transform it into bait-bearing strains with a prey plasmid. And so we have these strains where in one, as you can see at the bottom right, it is our bait-bearing strain of our HspB2. And so that's our examined, the one that we know it interacts with. And then the two on the left that we see are unrelated membrane proteins. And then we take colonies that have grown up on these plates, on these strains, and we put it on a selective medium to see if they'll grow on that. The idea of this selective medium is that only the bait HspB2 and our prey protein will grow on that, and the unrelated proteins will not because of the lack of interaction, lack of resistance. And so you see at the bottom where it says growth on selective medium. Under the unrelated membrane proteins there's no growth, and under the examined there is positive growth. And so that would show that HspB2, or our protein, our prey protein, was dependent on our HspB2 bait. However, if there was growth on the unrelated membrane proteins, it would show that our results were false positive, that the protein that we had isolated was not dependent on HspB2. Therefore, we can determine that it is a false positive. And so that's what we do just to ensure accuracy of our results. So I'm just going to quickly draw out how we would go about plating a dependency test. And so as shown in that image, we have one plate that would contain both our prey and our bait, so our HspB2 and our identified protein. And so we'll put that right here. And then we'd have our other plate. We'll put bait and prey. And we'll have our other plate that has our unrelated protein and our prey. And so we'll grow up some colonies on each of these. And then we'll take a colony from each of these. How do we do that? And we'll put it onto our selective medium. And we'll actually, so on the selective medium, on the back side of the plate, we'll divide it into sixths, just to keep track of where we are. And so we'll take one of these colonies here. We'll take it off this plate, and we'll streak it right across the top here one time with our sticks. And then we'll actually turn it to the other side of the stick, and the side that does not have colony on it. And then we'll take it from right here, and we'll drag that down, and then go back and forth. About halfway down, we'll get a new stick that has no product on it, and then we'll grab it from right here, and we'll drag it down. And so down towards the bottom, it should have less and less growth. But for this one, as we see, it's the unrelated, we're hoping for no growth here. Then we'll take a protein sample from our bait and our prey, and we'll do the same thing. We'll streak it right across the top, switch the side of the stick to a flat side that has no colony on it. We'll drag it from right here, then we'll go back and forth as we normally would. About halfway down, get a new stick, go from here, grab a little bit from there and then go down. Now on this one, obviously, we are hoping for growth. This one, we're not hoping for growth. And we'll do it 2 times with each protein just to verify that our results are correct. After we've done that, after we've plated those out, we'll wait for them to grow, and depending on the growth, we'll be able to see if it's a false positive or if it's dependent on HspB2. If it's dependent on HspB2, we will have growth with the bait and the prey, but if it is a false positive, we'll also have growth on the unrelated protein and the prey. And so that is a quick rundown on bait dependency testing. And just here at the end, here's kind of what it would look like once plated out. A few examples here on the right. Obviously, you see 1, 2, 3, and 4 have growth, and then 5 does not. And so what we would hope that would be is that 1, 2, 3, and 4 were bait and prey, and 5 was the unrelated protein and the prey. Also, you can see on the left side similar things with some of these plates. And that's just to make sure that we're eliminating all false positives and making sure that these proteins that we sequence, that we find out interact with our bait, with our HspB2, are in fact dependent on HspB2. Now, open up for any questions on the bait dependency testing that either Jonathan and/or Dr. Gross will be able to answer for you. Thanks.